Welcome to Savitha Dental College Lecturecast in Prosthodontics Impression Making. The major topics in this discussion would be the definition, classification, theories of impression making, principles of impression making, and primary impression making and secondary impression making. An impression is defined as the negative registration of the entire denture bearing, stabilizing, and border seal areas present in the edentulous mouth. Now let's look at the classification. Impressions may be classified based on the theories as mucocompressive, mucostatic, and selective pressure impression, based on technique as open mouth and closed mouth impression, based on the tray used as custom tray and stock tray impression, based on the purpose as primary and secondary impression, and based on the material as rigid and elastic impressions. The three theories of impression making are mucostatic, mucocompressive, and selective pressure impression techniques. So, mucostatic theory was proposed by Richardson and popularized by Page. So, basically, there will be tissue contact at rest. The denture will have very good retention because the tissues are recorded at rest and the denture will adapt perfectly at rest. In function, when the mucosa sinks, areas where there's excessive tissue thickness, the denture will sink more and it will rock around the bony projections. Carroll Jones proposed a mucocompressive theory which will record the tissues in function. So basically, a bite force or heavy pressure is applied when the impression is being made. And then the benefit of this theory is that we get very good stability in function. But when the tissues are at rest, they will push out the denture and there will be a loss of retention. It can also lead to more ridge resorption. Selective pressure uses the benefits of both techniques so that whichever area is more prone to resorption is being recorded in the mucostatic method, and whichever area can withstand resorption is recorded as a mucocompressive method. In this diagrammatic representation, we can see that on the left side there is perfect adaptation with the mucostatic impression where at rest, and a denture is being pushed out in a mucocompressive impression at rest, and in selective pressure some areas are at there is contact, some areas there's no contact, so it is neutrally over. In function, the mucocompressive impression has the best adaptation. The mucostatic impression shows rocking, and the selective pressure impression also has quite good stability. Next is objectives and principles of impression making. This is called as the press factors: preservation, retention, aesthetic, stability, and support. Preservation, Devan's statement is important where he states that perpetual preservation of that what remains is of utmost importance than meticulous replacement of that what is lost. Next is retention. It is the ability of the denture to withstand force of gravity, adhesiveness of foods, and forces associated with the opening of the jaws. The various factors affecting retention are anatomical, physiological, physical, mechanical, and muscular factors. The anatomical factors are the denture bearing area. Maxilla has a larger denture bearing area, so that has better retention than the mandible, which has only 14 square centimeters. Physiological, quantity and quality of saliva. If there's too much or too less saliva, it has to be corrected before impression making. Speaking of quality, you should have serous or mixed saliva. Too much of mucus saliva can affect retention. Physical factors include adhesion, cohesion, interfacial surface tension, capillarity, atmospheric pressure, and peripheral seal. Adhesion is the attraction between dissimilar molecules between saliva and the denture base. Cohesion is within the saliva or within the tissues, and interfacial surface tension between the saliva and the air. And capillarity is the ability of the saliva to flow between the denture and produce a stickiness. And atmospheric pressure is the suction or the negative pressure created due to the peripheral seal. Whenever you pull the denture out, it produces a negative pressure. Interfacial surface tension requires a proper air-water interface. So the upper denture will have better interfacial surface tension based retention because there is less amount of saliva. Whereas the lower denture, the saliva is basically soaked inside, and so you will not have good retention. For example, if you look at this glass slab, if you have a drop of water between the two, it will stick together. But however, if you have plenty of water, the slabs will come apart easily. They will not stick anymore. So the interfacial surface tension can be calculated by the Stefan's law. It is given by 2 by 3 pi kr per 4 by h cube into v. So k is a constant, r is the viscosity of saliva, h is the thickness of the salivary phlegm, and v is the velocity of the displacing force. This is an important formula. Next is aesthetics. The recording the flange and the contours of the flange properly in impression is important to make sure that the overall aesthetics and cheek support and lip support in the denture are also good. Stability, there are 5 factors affecting stability, namely the ridge height for soft tissue support, the kind of impression made, that polished surface contour, and the balanced occlusion. Balanced occlusion is the most important of all these because the occlusal plane and the ability of the denture to function with occlusal balance is important for good stability. Ridge height, better the taller the ridge, the better the stability. Firm soft tissue, 1 millimeter thick mucoperiosteum is the ideal soft tissue for making a good impression. Support, more the area, more the support. There's something called as a snowshoe effect, wherein a snowshoe with a wider base area will not sink more in the snow. Similarly, a denture with a larger area will not sink in the mucosa. It will have better support.